Good morning, everyone. We are doing a very important portion of coordinate geometry, the section formula. So far, we have learnt about calculating the distance between the 2 points given the Cartesian plane. Now, we will extend our knowledge towards finding out how a line segment joining any two given points in the Cartesian plane can be divided into a given ratio. The formula used to calculate this ratio is called the section formula, and the following video will help throw some light on how to derive the section formula. This is the YouTube video that has been made. So you can see this video. So I just explained that if I have this PXY, if I draw a line segment A given by X1, Y1 and B given by X2, Y2 and P is a point XY dividing AB in the ratio of M1 is to M2, then I can say that this X will be given by what? M1 X2 plus M2 X1 upon M1 plus M2, and Y will be given by again M1 Y2, go diagonally, M1 Y2 plus M2 Y1 upon M1 plus M2. So this is the section formula, and you can understand it seeing this figure again. So you can watch the video again to understand it better. We'll go now to this application. Let us watch this video to find out the midpoint formula. Now what is this? If I have a line segment AB such that A is given by x1, y1 and B is given by x2, y2, and I have a point P such that PXY is the midpoint of AB. Then what will AP and PB be? I can say that AP will be equal to, I say that AP will be equal to BP. If AP is equal to BP, then I can say that AP to BP is equal to 1:1. That means I have this ratio equal to 1:1. So what will X be? According to that formula, that section formula did, X will be equal to 1 into X2 plus 1 into X1. That means X2 plus X1 upon M1 plus M2. That means 1 plus 1. That is equal to how much? That is equal to X1 plus X2 upon 2. Exactly same way, Y will be given by what? Y will be given by 1 into Y1 plus 1 into Y2, 1 into Y1 plus 1 into Y2 upon Y1 M1 plus M2. That means 1 plus 1. So it's again equal to Y1 plus Y2 upon 2. So again we get the formula of the midpoint for any two for a line segment AB. If x1, y1 and x2, y2 are the endpoints, then the midpoint is given by x1 plus x2 upon 2 and y1 plus y2 upon 2. We begin with the exercise now. Find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio 2, 3. So what do we have? You take this line segment AB and you have a point P given by XY, which is dividing AB in the ratio 2:3. So very easily using the section formula, I think you all can find. Just let me know what are the values you are getting. X will be given by what? X will be given by, just see here, 2 into 4 plus 3 into -1 upon 2 plus 3, which is equal to 8 minus 3 upon 5, which is equal to 5 upon 5, which is equal to 1. And same way I can find out the value of y also. Y will be given by what? Y will be given by 2 into y2, m1 y2. That means 2 into -3 plus 3 into 7 upon 2 plus 3. So I get 21 minus 6 is 15 upon 5, which is equal to 3. So I get the point P will be given by 1, 3, and that is the answer. So this has been done for you also. I'll show you the solution. You can see x is 1, y is 3, therefore the point is 1, 3, and that is the answer. Right? So again, let us come back to the exercise 7.2 second question. Find the constant point of trisection of the line segments joining 4 minus 1 and minus 2 minus 3. So again, let us see the figure. I have the line segment AB and I have the points P and Q such that P and Q trisect this line segment. That means AP is to PQ is to P QB is 1 is to 1 is to 1. That means if I want to find out the coordinates of point P, this is 1 and this is again 1 plus 1. That means this is 2. So P divides AB in the ratio 1 is to 2. Can I use the section formula to find out the value of X and Y? Exactly same way. I can find out the value of Q using the formula, section formula, taking AQ is to QB as 2 is to 1. I could have also done it by I know the coordinates of P, I know the coordinates of B, then Q is lying exactly in the center of P and B. See, PQ is to QB is 1 is to 1. So I could have found out the value of Q by using the midpoint formula also. So let us see the way it has been done. P, X, Y, and Q, Z, Y be the points of trisection of the line segments joining A, 4 minus 1 and B, minus 2 minus 3. Then the points P and Q divide AB in 3 equal parts. Now these 3 equal parts, that means I can find out the coordinates of the point P. P will be given dividing AB in the ratio of 1 is to 2, the way I said. Using the section formula, I can find out the value of X and Y, which comes out to be how much? Just see here, Px will be given by 1 into minus 2 plus 1 into 4 upon 1 plus 2. So I get minus 2 plus 8 upon 3, that is 6 upon 3, which is equal to 2. And y will be given by what? Y coordinate will be given by minus 3 and minus 2, that is minus 5 upon 3. So I get the coordinates of point P as 2 minus 5 by 3. So similarly, Q, I told you we can do it in two ways. One, that Q will be the midpoint of P and B. Other, that Q divides AB in the ratio of 2 is to 1. So if I take it that way and use the section formula, I get the coordinates of point Q. X coordinate, that is Z, will be given by 2 into minus 2 plus 1 into 4 upon 2 plus 1 and 2 into minus 3 plus 1 into minus 1 upon 2 plus 1, which comes out to be
0 and minus 7 by 3. So this is how we can find out the coordinates of points P and Q.
Let us take up the next question. I'm doing the fifth question now. Find the ratio in which the line segment joining A, 1 minus 5 and B, minus 4, 5 is divided by the x-axis. Also find out the coordinates of the point of division. What do? I need to find out the point on the x-axis. Any point on the x-axis will be given by x comma 0. So I take the point P given by x0 and let us take that it divides in the ratio m is to 1. So if I divide in the ratio of m is to 1, let us try to make it the figure. I have point A given by my 1 minus 5, B coordinates are minus 4, 5, and I take the point P as x0 and I take the ratio to be as m is to 1. Now clearly I know this 0 will be given by what? 0 is the ordinate. So I'll use m1 y2 plus m2 y1 upon m1 plus m2 is equal to y. That means I get m into 5 plus 1 into minus 5 plus upon m plus 1 will be equal to 0. So putting that, what do I get? I get the value of y equal to 0. Once I put, I can find out that m comes out to be how much? M will come out to be 1. Now what is to be found out? I need to find out the x coordinate also. So m into minus 4 plus 1 into 1 upon m plus 1 will give me equal to x. So x will be given by how much? I'm putting m equal to 1, I get x equal to how much? X will come out to be minus 3 by 2.
So we can say that the required point P is given by minus 3 by 2 comma 0.
See the sixth question now. If 1, 2, 4, y, x, 6 and 3, 5 are the vertices of the parallelogram taken in order, then find the value of x and y. A very good question. One way is that you equate the opposite sides of the parallelogram are equal and then we try to find out, but that becomes very lengthy. But if we use the intelligent way to do it, if I know that the property of the parallelogram is that the diagonals of the parallelogram bisect each other. So if I use that, then that means that midpoint of AC will be same as midpoint of BD. What is the midpoint of AC? I know the midpoint formula. It will be given by 1 plus x upon 2 and 2 plus 6 upon 2. That will be the coordinates of point P, and it will be same as 3 plus 4 upon 2 and 5 plus y upon 2. So equating, what will we get? We will get that x plus 1 upon 2 is equal to 3 plus 4 upon 2. That means they are ordered pair. So first element of the ordered pair is same as the first element of the second ordered pair. And exactly same way for the second one also I can take these two are also equal. So x plus 1 will be equal to 7. That means x comes out to be 6 here. Exactly same way 8 upon 2 will be equal to 5 plus y upon 2. That means 5 plus y is equal to 8 and I get y is equal to 3. So I have got the values of x and y like this. So I hope it is clear. Let us take up the seventh question. Find the coordinates of point A where AB is the diameter of the circle whose center is 2 minus 3 and B is 1, 4. So what do I have? I have a circle with the center as 2 minus 3. Endpoints of the diameter are A and B. B's coordinates are 1 and 4. I need to find out the coordinates of point A. So this is how I'll be getting the figure. A is given by xy, B is given by 1, 4, and C point, the center is given by 2 minus 3. So one way is the distance of this AC is equal to distance of BC, but again that's a lengthy process. I know that the center is the midpoint of the diameter. So that means x plus 1 upon 2 is equal to 2, which will give me the value of x, and y plus 4 upon 2 is equal to minus 3. That will give me the value of y. So let us try to do it. The center of the circle is 2 minus 3. Then center will be the midpoint of the diameter. Therefore, I can say that using the midpoint formula directly, I can find out 2 is equal to x plus 1 upon 2. That means x comes out to be 3. Exactly same way, minus 3 is equal to 4 plus y upon 2. That means 4 plus y is equal to minus 6. That means I get y is equal to minus 10. So I have found out the value of x and y. That means A point is given by how much? The question was not to find out the value of x and y. The question was find out the coordinates of point A. So A is given by how much? A is given by 3 minus 10. Let us take up the eighth question now. If A and B are minus 2 and 2 minus 4 respectively, find the coordinates of P such that AP is 3/7 of AB and P lies on the line segment AB. Now, good question because the ratio is not 3:7. We will not take the ratio to be as 3:7, but we will be taking it to be as 3:4. Let's see how. Now, let's say I have a point AB. AB is given to us and I have a point P on it such that AP is 3/7 of AB. Now AP is 3 by 7 times AB. That means therefore BP will be how much? BP will be equal to 1 minus 3/7. That means 4 by 7 times AP. So AP is to BP will be given by 3 by 7 times AB is to 4 by 7 times AB. So this will come out to be 3 is to 4. So this is the important thing for you to know that AP is to BP is 3 is to 4. So let's try to do the question now. I have what? Let's try to draw the figure and show it, do it the question. A is given to you as -2, -2. B is given to you as 2 minus 4. I suppose the coordinates of point P to be as xy such that P is dividing AB in the ratio of 3 is to 4. So what will the coordinates of point P be? X coordinate, the abscissa of P will be given as 3 into 2 plus 4 into minus 2 upon 3 plus 4. And the y coordinate, the ordinate, that is y will be given by 3 into minus 4 plus 4 into minus 2 upon 3 plus 4. So let us try to find out what do we get. we get that x is equal to, say here, 3 into 2 plus 4 into minus 2 upon 3 plus 4, that is 7. So I get the answer as minus 2 by 7. Exactly same way, y can be found out to be as minus 20 by 7. So I can find out the coordinates of point P. P is given by minus 2, 7 and minus 20 by 7. So that is the required answer. Now we come to a very important result, the centroid of the triangle. You can watch this video and you'll be able to understand it very well. It has been explained properly. I'll tell you that for a triangle ABC, if I have a triangle ABC given to me, A having the coordinate as x1, y1, B as x2, y2, and C as x3, y3, then the centroid is given by what? Centroid is given by x1 plus x2 plus x3 upon 3 and y1 plus y2 plus y3 upon 3. So this is the formula for the centroid of the triangle. You can find that out. You can prove that using this video. You can easily, it's been done properly for you. You can watch it later on. Now, let us try to do this question. Find the coordinates of the point of intersection, the medians of the triangle ABC, given that A is minus 2, 3, B is 6, 7, and C is 4, 1 are the vertices of the triangle. It has also been solved here for you all. You can use this. You can watch this by this video also. The complete question has been done for you. Now this finishes off with the questions of the exercise. You have these questions to be done as homework, and there is one more important thing to be done, the area of the triangle. Remember that if I have ABC as the vertices given to me, area is given by half into, let's begin with x1, and we put a bracket, plus
x2, and again we put a bracket, then plus x3, and let us put the bracket once again. Now what is to come in the bracket? Let us decide that. Now just see the order 1, 2 and 3. After 1 we get 2, after 2 we get 3, and then again we go to 1. So x1 followed by y2, y2 followed by y3. So x1, y2 minus y3 plus x2 followed by y3 minus y1 plus x3 followed by y1 minus y2. So remember, see the order here. We have 1, 2, 3, x1, y2, y3, x2, y3, y1, x3, y1, y2. The order is remaining the same here. So this is how you can learn the formula and you can apply it in the questions. Though direct question of the area of triangle will be not asked in the year 2020-21. But yes, you can always use this formula to prove the 3 points collinear, because in case the 3 points are collinear, what will happen to the area? The area of the triangle in that case will become 0, and this formula can be very well used. Instead of adding up all the 3 distances and then showing that they are collinear, I can simply find out the area and show it to be 0. So this is the formula that we have discussed. It is written here neatly. You can see it up.
And let us take up the example of the learned formula. Find there is a triangle given by the points. So again, how will we get? The area will be given by what? The area will be given by half into x1. x1 is minus 1.5, then the bracket, plus x2, 6, then the bracket, plus x3, that is minus 3, and then the bracket. After 1.5 you have y2, that means minus 2 minus 4 plus 6 into how much? Y3. 4 minus 3 plus minus 3 into what? Minus 3 is by x3, so we'll put y1, 3 minus of minus 2. So that means it will come out to be how much? It will be equal to half into minus 1.5 into minus 6, that means plus 9, plus 6 into 1, that is 6, minus 3 into 5, that is how much? So minus 3 into 5, which is equal to minus 15. So how much do I get? Half of 15 minus 15, which is equal to 0. So can the area of the triangle be equal to 0? I cannot have the triangle with the area 0. That means that the 3 points are collinear. So the condition for the points to be collinear is that the area of the triangle is equal to 0. Now the complete question has also been done for you. You can see it up properly. The area is coming out to be 0, means that the vertices are collinear. Kindly go through the video again to understand things better. Thank you so much.